So use the table below. Use the table below to fill in the missing values. Okay, so we have these x values and then these f. Now remember, f of x is the same. I'm right up here. F of x is the same as y. So these are basically y values. So x values and y values. X values and f of x values. F of x is the same as y. So that's an important thing to know all the way through this part of the course. F of x is exactly the same as y. Okay, so they're basically giving us some x and y, right? They're saying, and here's how it works. They're saying this x value leads to that y value. You know, x of 0 leads to a y of 3. X of 1 leads to a y of 7. X of 2 leads to a y of 6, etc. They're connected, like inputs and outputs. Like I could say, okay, I've got a toaster. I could say I've got some x values and some f of x values for the toaster function. I know it sounds crazy, but I think it'll help. I could say you put in bread, you get out toast. You put in frozen waffles, you get out toasted waffles, etc. Right? Making sense? Just input, output, right? That's all we're talking about in this. Bread leads to toast. Frozen waffles lead to toasted waffles. Just like 0 leads to 3 and 1 leads to 7 and 2 leads to 6, etc. It's a connection between inputs and outputs. The toaster turns the input bread into output toast. The input frozen waffles into output toasted waffles. In the same way, this function f of x, whatever it is, we don't know, turns 0 into 3, the input 0 into the output 3, the input 1 into the output 7, etc. Okay, coming on down, let's answer the question. They're saying, what is f of 3? Well, this is an x value, right? Because for a normal function, you put in f of x, and what it equals is y. That's why I can say it's the same as y, because it's equal to y, right? You put in x, you get out y, right? For a normal function. And then for an inverse function, that's reversed. Okay, so if they put in 3, well, that 3 leads to 9, doesn't it? From the table. This table is telling us how this function works. You give it a 3, it's going to come out a 9. It turns a 3 into a 9, like a toaster turns bread into toast. Okay, what about this? If f of x equals 5, then what's x? Well, now on this next one, they're giving us the y. This is the y value, and they're asking us what, right there, what x value leads to the y value of 5? You see that? Remember, what goes in is x, what comes out is y for any regular function. So they're saying, what went in? What was x that went in that came out of 5? It's right here. You put in an x value of 7, you get out a y value of 5. So that x value, x must have been 7. Is that good? Questions I can answer so far? Now let's keep going. Down here, this next one, same question. And now it's saying f inverse. Notice the inverse there, right? And how does f inverse work? For an f inverse, you put in y, get out x. It reverses it from the regular function, doesn't it? You with me? It reverses it. So therefore, this 9 right here is actually y. They're saying, go find the y value of 9 and tell us what x it's connected to. Well, it's right here. Right? Y value of 9 comes from the x value of 3. 3 leads to 9 for a regular function. Reverse, 9 goes back to 3. So this is 3 is the answer there. Do you see what I'm doing? I'm just identifying if they're handing me an x or a y, and then I'm going up to the table to find the other x or y that goes with that x or y. Right? So one more time, Right here, I knew this was an x. How do you know? It's inside of a regular function. Inside of a regular function is always x. And then I went, oh, okay, they want the y value then. Go find x is 3. So I found x is 3 and said, oh, 9 goes with it. So I gave them 9. Whereas down here, they gave me 9, but it was in an inverse function. That means it's a y. So they gave me y9. So I went and found y9 and give them the x that goes with it. Let's try this last part. Now they're saying f inverse, and then they're giving me this x right here. And they're saying 7. Now, this is where it could get really confusing. I've been trying my best to make it as simple as possible. And sometimes, honestly, I go too far and I oversimplify. Really, when I say, you know, it's got to be x inside and y outside, I'm trying to help you and make it clear. But the truth of the matter is, x and y are just letters, and you could use any letter. You could use A, B, C, D, E, F, G. You can use the whole alphabet. You call it Joe and Tom. It's just a letter, a variable. It can be anything. So I say all that now. Now I'm kind of backing off of my XY stuff, even though it's true. I'm still giving you what's true to help. But I don't want you to look at that X right there and think, oh, that's got to be an X like X in this table kind of X. It's not. How do you know it's not? Because it's inside of F inverse. See it right here? What's inside of F inverse? What's always inside of F inverse? Y. That's really what we commonly call Y. Yeah, but they're calling it X there. Yeah, they could call it Joe or Mary. It's just a name. So really, what you need to think is positionally. You need to think, where is the thing sitting? If it's sitting here inside of an F inverse, it's really going to come from the right side of the table. So maybe that's what I should do to be more clear. Yeah, how about that? So maybe this would be more clear. So let me change my game plan. So for a regular function, you plug in what's on the left, you get out what's on the right, whatever you want to call it. For an inverse function, it's vice versa. You plug in stuff from the right on the table, and you get out stuff from the left, whether you call it X or Y or Joe or Tom or whatever. How about that? Is that more helpful? Usually X and Y is fine, but they're being kind of tricky here. So let's just go with that. So when they give you that X there, it's inside of F inverse, which means it's from the right, really. So you're looking, and this is really from the right. And then what it equals is from the left, right? The outside of an inverse function, what it equals is from the left. So go find 7 on the left, right there. There's 7 on the left. And what does it go with? 5 on the right. So this is 5 on the right, so X is 5. There we go. Is that good? So normal functions, take stuff from the left, change it to the right. Inverse functions, right to left, backwards. And so when they give me this 5, that's on the right. It goes back. Or I'm sorry, they gave me the 7, which connects with the 5. There we go. I better stop while I'm ahead. There we go. That's how it works. So inverse functions just run things backwards is what they do. So the main thing you need to look here is what's in the parentheses on the right. What comes out is on the left. 7 on the left. Go right there, goes with 5. So there we go.